Hey guys, welcome to the third tutorial. Now in this tutorial I'm going to show you how to make a very basic Arduino schematic. Now say for example, let's start with Arduino Uno. Now here we have an Arduino Uno. Now these Arduinos generally have three major modules. The first one being the Atmega 328P IC, which is your main microcontroller. Second module being the bootloader IC, which is also an Atmega 8U2 or a 16U2 microcontroller. And the third and the most important module being your power module in this area. So the power module generally has a DC barrel jack, two voltage regulators, one being a 5 volt one, the second being a 3.3 volt one, and some filtering capacitors. Now, since to keep things easy, let's delete the bootloader part and we can use some external programming chips like CP2102 or say for example FTDI board, which are USB to serial converters which can also program your Atmega 328P. So we are going to try and make something like this cheater board over here, which I made like something around 2 years ago for a company I was working for. And so you can just connect your CP2102 with some basic jumpers and program this little thing. Now coming to the power module back, our Atmega 328P can be given a wide voltage range starting from 2.7 volts to the highest range of 5.5 volts. So keeping things simple on our board, we'll just use a 7805 voltage regulator along with some filtering capacitors. So let's get to the schematic and start adding some components. So let's go to File, New, Schematic, and here I have my new schematic. Now let's start adding components one by one. Now before you add components, let's just establish an order in which we'll be adding these components. So fellas, before you start designing any circuit, make sure you know the power level of each and every component in the circuit. In this case we have the Atmega 328P, which has a wide voltage range starting from 2.7 volts to 5.5 volts. Now to keep things simpler and easier, we'll just go ahead with the 5 volts voltage level because that's what most sensors are compatible with. So let us just focus on the power module first, which is just a 7805 linear voltage regulator. So I'm gonna go click on add. So here we have the add window. I'm gonna just type in 7805 and here we go, power IC. Now this is the SparkFun Eagle library. So let's just try using components from one single library to keep things easier. So here we go, 7805. I'm gonna select and click on OK. So I have my 7805 over here. Now let's add some supporting components such as capacitors. So every 7805 needs an input capacitor and an output capacitor, for which I'm going to use the RCL library, and I'm going to use the polarized US capacitor. I'm going to scroll down this one. Yeah, I'm going to need one at the input and the second one at the output. And how am I going to supply power to this board? I mean, what kind of connector? I'm going to use a DC barrel jack. So here we go, Adafruit also has DC barrel jack, but let's stick to the SparkFun library. Here we go, power jack. Now there are a variety of options. Now this is a SMD one. Again, this is a combo. Yeah, this thing looks perfect. So I'll just click on OK. And here we go. Here is the completed power circuit. Now to quit adding, I'm gonna hit escape. Now, so let's just complete our power circuit. So I'm going to use the net tool over here to easily connect these two things and the ground. Now I need to add a ground symbol over here, for which I'm going to add and say type ground. So here we go, SparkFun aesthetics. ground. This is the ground symbol, and I'll just add one over here, and I'll hit escape. I'm gonna go back to my net tool. It says merge net segment N$3 into supply net ground. So this net is N$3 and I'm going to supply ground to it, so it gets connected. These two things are ground and this is the main supply. So I'm going to short these two things, and the main supply goes into the input of the 7805, so it can be somewhere around 12 volts. Now I'm going to copy the ground and put it over here, or let's just say, to keep things simpler, I'll just short this thing to ground, and here we have our output 5 volt supply. Now I can rename this thing to VCC. So I'm going to use the name tool to rename this net from N$2 to VCC, which is 5 volts. Here we go. And I'm going to add a label so that I come to know this thing is 5 volts, which can be easily done with the label tool. Also, you can, if you want to add a power symbol, I'll just type in VCC. Again, we have SparkFun aesthetics and a topwards pointing arrow, which also says VCC. I'm going to use the net tool. So here I come to know that this thing is the output power, which is the regulated power. Now we are done with our power module. So let's start adding the components required for Arduino. I'm gonna erase the search and I'm gonna scroll back down to SparkFun. Let's go into digital IC. Now digital IC has all the logic ICs as well as microcontrollers which we want. So let's just go to Atmega 328, which is the controller on our Arduino. Now this is the SMD version. Whenever you see a brown or a orangish pad over here, that is a SMD version, and if you see green holes, that is the DIP version, which is the through hole version. Here it says in the description, microcontroller used in Arduino, 32 KB flash, 1K EROM, 2K SRAM, the exact one which we need. So let's just select this thing and click on OK. So here we go. We have added the microcontroller. Next thing we need is our crystal. Now I can find a crystal in SparkFun clocks, and we need a 16 megahertz crystal. So we have SMD. Again, we have brown pads which are SMD, and we have this through hole crystal. So I'm going to select through hole crystal since we are designing a single layer PCB. Now every crystal needs some capacitance. Now I'm not going to go into SparkFun capacitors. We are going to RCL library. I'll just say C polarized. I don't need polarized right now because this is just a disk capacitor, so we'll need 2 of them. We also need a resistor to pull up the reset pin. Grid says 7.5 mm, which is the distance between the 2 holes. Now this 7.5 mm grid is generally the distance between a 1/4 watt, which is a 0.25 watt capacitor. So I'm going to select this. We also need a switch, which is a reset switch. So I'm going to come down to SparkFun switches, and let's just say momentary switch SPST, the tactile one, and there are a lot of options. Again, this is the DIP one, SMD one, this is the one found on your Arduino Nano. But since we are trying to replicate the Uno, let's just go ahead with this one. Here we go. We have the momentary 6 mm switch. Now let's quit adding components as of now and make some connections. So let's just do the connection of the crystal over here. Now I'm going to copy the ground. I'm also going to copy VCC. So there we go. Here is the reset pull up. Now this thing has a really big name, so I'll just, the name is S1, the value is this big thing, so I'll just use the value tool to, I'll just say SPST. I need one more ground. So when you short this thing, the Arduino gets resetted. So here we go. We have completed the basic connections of a basic Arduino. Now obviously you have a 13 number pin which is right over here, PB5 SCK, and it has a 13 number LED. So let's just go and add that as well. So I'm just gonna type LED. Yeah, let's keep things small over here. So we have an LED. Also we need a resistor from the RCL library. Now I need to copy the ground. Now let's give all the components the required values. 10 UF is good to go with. Same goes for this one. 10 UF, 22 picofarads. Same for this one. Pull up is always 10 kilo ohms. Well, let's say 220 ohms is enough, and I want this LED to be green. That's it for this tutorial. In the next one, we will add the programming part and arrange the components in a professional way. So watch out for the next one.